I put together a few extra problems for us to go through in terms of conversion factors that take several steps, and even some cubed units and some double units and how to approach those types of conversion factors. If we're dealing with seconds and we're trying to convert to hours, the first thing I would do is I would just make some equivalence statements for myself. I know that 60 seconds are equal to 1 hour, or 1 minute, I should say. And I know that 60 minutes are equal to 1 hour. So to do this, I would set it up the same way with my 22.4 seconds on one side of my conversion factor chart, and I know that I want to convert to hours. First thing is, I'm going to take my first equivalent statement that I made, 60 seconds. 60 seconds are going to go on the bottom. 1 minute goes on the top. Seconds divide out, and I'm stuck in minutes. I am done with this equivalence statement. For the second equivalence statement, I want my hours to be on the top, so I'm going to take 1 hour, put it on top. 60 minutes are going to go on the bottom. If I do that math, I find that my final answer is 0.00622 hours. So that's a situation in which your conversion factors could be things that are not in the SI system. You can use conversion factors for anything that you can design an equivalence statement for. You can also work with cubed units. This comes up sometimes if you're going from cubic centimeters to cubic meters. So the same thing holds true. I'd start with cubic centimeters, and we know that 100 centimeters is the same as 1 meter, but here's the problem. This unit doesn't match this one. So a trick that we can use is we can actually take the entire conversion factor to the third power. I take 1 to the third power, it stays 1. I take meters to the third power, that is meters cubed. I take 100 to the third power, and that is 1 million, or 10 to the 6th. And my centimeters become cubed. And then this problem becomes a little bit more straightforward because now that my units match my original units, I can divide them out, and I would simply just divide by the number 1 million to get my answer below. Sometimes we're working with units that are expressed in double units. So I have 0.67 grams per milliliter. There's another way that I can write that. I can write that as 1 milliliter on the bottom here. And my goal is to get my final units to be centigrams per liter. The first thing I would do is I would try to get my top unit to be centigrams. So I know that 100 centigrams is equal to 1 gram, and that takes care of the top. However, the bottom is still in milliliters. To get rid of milliliters, I need to find some equivalent statement to make it equal to liters. So what I can do is I can say 1,000 milliliters is the same as 1 liter. After I do all of that math, my milliliters cancel out with my milliliters over here, and I'm left with centigrams per liter. And my final answer becomes 67,000 centigrams per liter. To convert meters per second to miles per hour, I do pretty much the same thing. 5.4 meters per 1 second. To get rid of meters into a more useful unit, 1,000 meters are the same as 1 kilometer. And that gets my top unit into kilometers, which I can now switch to miles, since I now know that 1 mile is the same as 1.61 kilometers. I have miles in my numerator. I need to work on my denominator now. So I know that there are 60 seconds in 1 minute. And I know that there are 60 minutes in 1 hour. Wow, that was a lot of conversion factors. I can do as many of these as I want in a row, but you'll notice my top units are miles, my bottom units are hours, so my final units are going to be miles per hour. And my final answer ends up being 12 miles per hour. Are these problems going to be ones that you see on your quiz or on your test? No. But some of you might take an honors level science class after this, and I wanted you to at least see all of the different directions that you can take conversion factors.